Hello everyone, I hope you are doing good. In the previous video we learned about vector. I taught you how to insert a value inside a vector, how to pop out, how to push back, and how to calculate the size, how to assign, and how to reserve, how to see the front, back. I hope you got the basic concept of vector and you understood it clearly. You can see there are a lot of functions which are related to vector. You can see them in the docs, and I hope you have done the exercise that I gave about function. I did not give about vector because vectors and arrays are related, so you can just do the questions of the array with the vector. So I gave you questions about function. I hope you did it. And so today we'll learn about dynamic memory allocation. So let's come here and just today we'll learn about dynamic memory allocation. What is dynamic memory allocation? Means now whenever we initialize a variable, it is directly assigned. It's, it's, it's assigned directly. We initialize it with some number. But what if you wanted to initialize it whenever we want in the later part, and it won't take so much of hassle. So you'll understand it when I give you some examples. There are two new terms that you will learn while learning dynamic memory allocation, that are new and delete. These are the terms that you will learn in dynamic memory. These are very important. Don't forget that new and delete. We'll do some example. You'll get it very clearly about what dynamic memory allocation is. Okay, let's begin. I have just wrote here the int main function, so just comment out this. Okay, sorry. Okay, let's run the int main. I'll just show you with the help of some data types. Okay, first of all we need to write a pointer. Okay, I have already told you about the asterisk sign and name here, and how to means assign with an address here. It is a pointer. I said you in the when we discussed about pointer, so I hope you don't face any problem just initializing it and you understand what this is. Now to allocate a memory, now we introduce the data type. What type of data it should contain is contain p int, and the name is asterisk p. So now what is inside the p? Inside the p will declare a integer. Sorry, we'll just write new data type and the number we want to introduce. So this is how you can dynamically. If you did not do like this, you should have been done like this. You can do like this, equal to 10. So this will initialize a value. So this is static. This is do you say this hard coding? But you don't want to do hard coding. You wanted to initialize it this way so that you can dynamically you can do it. It's not static. Anyone can introduce here. You can just write here n, and whenever someone enters the value of n, it entered here and the value get assigned. So this we should write the name of the variable of which we write asterisk, and this variable name of the variable equals to new. This is a new keyword in the C++ library, and the data type and the value that we want to enter. Now how do we print out? We can just write cout p and just run it. Okay, p is giving the address. We are getting the address of, I hope it's running the same file that we want. Okay, p is giving the address where this value is stored. We wanted to access this 10, but where is this 10? So 10 is stored inside this p. This p is the address of this value. Now what is the value? Value is stored in asterisk p. So if you just write here the asterisk sign and just run it, you can see the value 10 get printed. Okay, I will just clear this and we'll write here address and value. Just run it. Okay, see, you can see that we got the address where the 10 is stored. It is stored in this hexadecimal number. I already said the address are in hexadecimal, so this is where it is stored and the value is 10. So that's how you can dynamically put here. You can write here float, boolean, whatever you want. You can just write here the data type. You can change the data type and put whatever. and that's how you can initialize it dynamically. You can initialize dynamically any type of data type, and you can access them by using these notations, and that's how we go. Now we'll talk about how to dynamically write an array. This is very important, and you'll probably get a lot of problems when you dynamically do arrays. So I'll try to do this in simple way. Okay, just comment out this. Now we'll initialize dynamically array. Okay, int main. Okay, first of all we need to write what data type, and okay, we'll write arr so that you understand. Okay, we initialize it. Now you just need to write arr equals to new int of how many, suppose 10. Okay, this is how we initialize the array which can contain 10 value of type int. Okay, now let me talk one by one. First of all, in the previous we saw how to initialize it. In the same way you can initialize it for array. This is the address where it will store, and this is how we initialize an array with 10 spaces, 10 space inside that arr. Now this can contain, you can see, I'll just fill up this array so that you can understand clearly. Okay, for int I equals to 0, I less than 10, I plus plus. Okay, this arr of I equals to I, and we'll just write one more time this, control C, control V, and so we'll just print out this C out. Okay, just run it. You can see we initialize it. We did it dynamically. How we did it dynamically? We can see first we initialize the variable, then using the new operator we got the some spaces. If you write in parenthesis, then you directly initialize it value. And if you write in this square braces, then it's like array, it is consuming some space of 10 but with no values, some garbage value. And okay, if you wanted to see, I'll just comment out this, just run it. You can see there are some garbage value. This value we don't know this value because we don't initialize it, so it is whatever is, but it will consume only 10 spaces. You can see 1 2 3 4 5 6 7 8 9 10, because we gave it only 10 spaces. That's how you can initialize an array dynamically. So what if you wanted to initialize it? Okay, before doing it 2D array, let me say one thing. We did not use the delete operator. Delete operator is very useful. You can see. Okay, let me come back to the data type. Okay, now we wrote the we put the value, we dynamically initialize with the value, but there may be some memory leaks. So to avoid the memory leaks, we can just use the delete operator. Just write delete. Okay, this error, delete, and the name of the variable. What is the variable? P. So that's it. Now if you control run this, okay, this is okay, I'll show you what I wanted to show you here. So if you just run it, you can see you got an address of this and the value of 10, but now you deleted it. Now what if you printed out this? One second. Okay, just run it. Okay, you can see the address is okay, let me put here endl, just run it. Okay, you can see the addresses are same. This P has an address and this P has an address, and the address is same whatever if you delete or don't delete. But you can see the value. We initialize the value 10. Second time is a garbage value. Means what? This address is ready to look any value. It is the variable is declared, but it did not take any input. It is free of that input. The input we got 10. So that's how we can avoid, means we can avoid memory spaces by just deleting the deleting the variable that we declared by dynamically. So don't forget, when you use a new, don't forget to delete whatever you declared so that the memory leaks don't happen. You can read about memory leaks when you read the docs about a dynamic memory allocation. You'll understand it more clearly. So that's what I wanted to say, that whenever you dynamically memory, whenever you do that with new operator, don't forget to use the delete. But what if we are doing with array? This is for integers, this is for just simple data type, so that's why you wrote delete p. But what if you have to delete it for an array? So to do with array, just me comment out this and come back here, just uncomment this. Here we declared for array, but how do we delete this? You can just write delete, use these braces and just write arr and run it. You can see everything is normal, means now this error. Now what if we printed out this once again, just run it. Okay, you can see till 9 is printed. After that this all gets cleared and it's again filled with these garbage values. It's not the same number that you have, it may be look same, but these are all garbage value. It can print anything in this place. So that's how you can get rid of all this. That's why that's why I want to make clear about new and delete. I hope you understood what delete and new int means. So there is one more thing you can do with pointers. Before deleting, let's just delete this, and you can just, okay, let me use a pointer sign and just run it, asterisk sign, sorry. Okay, array have int, see your error, wait a second. We are facing an error here. Wait, I'll just show you something. Wait a second, guys. You can see the value gets printed. We can do this type using this asterisk pointer. I did not say you did about pointer, I just forgot it there, but you can use it this way. We can just write point this asterisk sign, and inside this we can just declare the variable plus the value of I. So before now, what if you wanted to know what is the size of integer? You can do one thing, you can just remove this and just run it one more time. You can see the address get printed. So see the address once and see it here, 0 4 8. There's a difference of 4, and this is in hexadecimal, so there we are getting C, B and all that, but you can see there is a difference of 4. That 4 means integer take up 4 bytes in the computer. Okay, this clear. Integer take up 4 bytes. And what if we changes this? What if we change this to double? Okay, this to double, and just run this. We can see now the spaces between two number are 8. Why it is 8? Because the double take up 8 bits, 8 bytes of space in the memory. That's how you can do, means find the value of inside, find the values of array by not writing arr and this square braces and putting the I. You can find it in this way also. Just use this asterisk sign here and just run it. You can find all the values. That's how you can do. And what if you want to do for 2D array? So for 2D array, when you declare this, just use two asterisk. Okay, and before initializing it, just write one star here. Okay, put one star means what? This array is declared for 1, but this is also pointing to something. We write asterisk 10, this is also pointing to something. And to do this, we should use a for loop here. Just write here once more time, arr is equal to new double of I. Okay, what does this mean? Inside this array, first of all, this array arr, we are using 10. 0 to, it is counting 0 to 10 in the vertical direction. I hope this is vertical. Yes, this is in the vertical direction. Okay, I'll just try to show you. So it's counting like this: 1 2 3 4 5 6 7 8 9. It's counting this way, and we use one more for loop to count it in this way. After 1 it will count in 2 3, means it will. Guys, this video is getting longer. We'll continue in second part. So now is counting in 10, means it is creating space for 10 values in this way, in the vertical direction. But for 2D array we should go in the horizontal direction too. That's why for every one space, for this one there is one more counting: 0 1 2 3 4 5 6 7 8 9. So now we got 2D array. We got a vertical and the horizontal. This way we are creating a 2D array. Because we wanted to create a 2D array, you use two asterisk sign. Use the two asterisk sign, and we declared it for 1D. But don't forget to use this asterisk sign. This says that this is just a reference. This is for the vertical, and we have one more array inside this. So we use the for loop, and inside this every variable, every position of the variable, we have one more array that is in the horizontal direction. I hope you got a little bit idea about it. Just let's run it. I hope we don't get any error. We got an error: cannot convert double to double in assignment. Okay, wait a sec. Cannot convert double to. I hope we are getting. There is an error somewhere. For which position should be in horizontal spaces too? So just like 1 2 3, we need this horizontal for 2D also. So we don't initialize which position. We should just write entire. I think it should solve the problem. Just let's run it once. Okay, there is an error of this. So just run it. Okay, it's running good. Now just let me write a for loop. I'll just copy paste. I have a for loop here. Control V. Okay, this is simple. I just wrote it before so that I could copy and paste it here. So you can see that there is a for loop, and we are initializing this with a value. I hope you got this. I have talked about 2D array, and if you don't know, please watch the video so that you can understand this. So we'll copy this one more time and paste it here, but this time we will use one curly braces here. I'll say why we are using curly braces, because we wanted to write this C out. So after every printing out, after every values, we want there should be a break of line so that you can see it more clearly. Let's run it this time. I hope that we have no errors. Of course we have some errors. We can't do anything without errors. Okay, finally we got. Just let me clear out this. Write it one more time. Okay, you can see that we got the 2D array: 0 0 0 1 1 1 2 2 3. There are 3 rows and 3 columns. And how we did that? Using this dynamic memory allocation, we just use two asterisk sign. We wanted for 2D, that's a 2, and we initialize this with 3 spaces, but 3 spaces include some more spaces, that's why we include the asterisk. And for every position, that is ARRI, we initialize 3 more spaces. That's how we initialize, and this is just simply putting the values and printing the values out. And we know that after, if you use new, always use delete operator. Delete this and the name ARR, and just run it. It will run the same. Okay, but the memory is getting deleted. I hope you understood the basic concept of how to do array 1D 2D. I've shown you both. If you want some more details, you can just see up the internet and learn some more new awesome things related to dynamic memory allocation. We'll do more about dynamic memory allocation when we learn about classes object oriented problems. There will get some problems there, and you will use dynamic memory. That's why I wanted to explain you here. So I hope you got the concept. Now I have some exercise for you relating with this two exercises. For the first, using dynamic memory allocation, create a 1D array of type int float double, taking the length and values from the user. Means you should take this and the values from user. You can simply do this using the cin operator. I hope you can do this and just print out this. This is very easy. And second, create a 2D array using dynamic memory of type any. You can do of any type. I have done using int. You can do it float, double, anything. Taking the length and values from the user, print the value out. This is just this one, same to same as this. I have done for double. Do it for int and float, and it's same. Just take the value of, I wrote here 3. You just write n and just write here int n cin and just write this way. And I hope you can solve this. Please do the exercises. If you do the exercises, you understand it better. So do these two exercises, and in the next we'll learn about recursive function. So recursive function is very useful. Recursive function is like just performing function inside function. It is simple but it's very useful and very strong. So we'll learn in the next video. See you in the next. And please watch the previous video if you face any difficulties relating to for loops, arrays. So thank you guys for watching. See you in the next.